Let's take a look at solutions, molarity, concentrations, and dilutions. All right, so we've got solution. A solution is when one substance is dissolved in another. So a solution is one substance is dissolved another. You studied solutions in one previous grade a lot. You talked about mechanical solutions, like salt and water. Then you've got ionic solutions, mechanical solutions like sugar and water. You've got solutions like salt and water, where the two parts of the ion actually get taken apart from each other. There's many types of different solutions. We've got a couple of simple examples: salt and water. The chemicals don't form new compounds. So it's not a chemical reaction. In the strict sense. I mean, it kind of is, because in an ionic solution, like salt and water, the anions, so I'm going to say cations first, that's positive, cations and anions break apart. So when you dissolve salt in water, you have like a sodium, Na, with a chlorine. But then when you put it in water, they separate from each other. And so you get sodiums and you get chlorines in the water. So the solute is what is being dissolved. The solvent is what is doing the dissolving. Right? So there's always more of the solvent than solute. All right, so aqueous solutions, having water as a solvent. We call water the universal solvent. It can dissolve a lot of different things. Solutions can be liquid, like vinegar and like pop, where you dissolve stuff in water. They can be gaseous, like air. In gaseous, we'd say the solvent is nitrogen gas because it's the most, and then everything else is dissolved in it. Or solid, like window glass or brass. Sterling silver is a solid solution. If you've ever bought sterling silver, the copper atoms are dissolved in molten silver and mixed uniformly. When the solution solidifies, the copper atoms are distributed evenly throughout the solid. Right, so this is common in metals, and you make sterling silver with copper in order to probably increase the rigidity, the hardness of it, so that when you shape it into something, it stays in that shape better. Gold often is like this. Gold often has stuff dissolved into it. Right, now solutes, like it says here, solutes have to be mixed evenly. They have to be mixed evenly. So it has to be distributed evenly throughout the system. An unsaturated solution can hold more solute. So you can dump more stuff into it. You can put more salt in it. So if you have salt and water, right, you have the water, you put salt in it, you can dissolve a certain amount of salt. If you can dissolve more salt in it, then it's unsaturated. It hasn't taken as much salt as possible. Saturated solution cannot hold more solute. So you're dumping salt in your water, and eventually your water can't absorb any more salt. And you just get like salt floating around in the water because the water has become saturated. It has filled up with as much solute as possible and it can't hold any more. That's when it becomes saturated. Solubility refers to the amount of substance needed to make a saturated solution at a specific temperature. So that's a chemical property that we could look up. We could look up how much salt will water dissolve at a specific temperature. The higher the temperature, usually the more it can dissolve. And for sugar, the solubility really changes for temperature. For salt, the solubility changes a little bit for temperature, but not that much. So solution concentration. The concentration of a solution tells us the number of moles of dissolved solute per liter of solvent. Okay, so think the number of moles of salt per liter of water. So molarity is equal to the moles of a solute divided by the liters of solvent. I usually write this like this. The molarity is capital M. This is why I didn't like using capital M for molar mass, because when we talk about solutions, molarity is capital M. Is the number of moles per liter. So this is moles of the solute, and this is liters of solvent. Concentration is represented with square brackets. Okay, so the concentration of AgNO3 is 2.50 moles per liter. So we've got 2.50 moles of AgNO3 in 1 liter of solution, in 1 liter of solvent. Or we call it 2.5 capital M. All right. So we're going to do a couple questions, and then we're going to get into some more complicated questions. So calculate the, square brackets, the concentration of the solution in which 0.275 moles of AgNO3 are dissolved in water to make 2 liters of solution. So we've got 2 liters of water, and we're dumping in that many moles of AgNO3. So capital M is equal to moles per liter. Now I don't have a lot of space here, so I'm going to put the next one over here. I don't usually like to arrange my equal signs in a horizontal line, but we will. So we've got 0.275, and this has 3 significant figures, and this 2.00 also has 3 significant figures, so our final answers should have 3. Sorry, not 2.57, 2.75 divided by 2.00. That's really terrible. But you know it's 2.75. So we take and we do that. Calculator. 2.75 divided by 2.00 equals 1.375. So 1.375 M. That's our concentration, capital M. Now, we want this to have 3 significant figures because both of these did. When we divide, we take the lowest number of significant figures. Since they're both 3 significant figures, the lowest amount is 3. So we make it 1.38 concentration. So the concentration of AgNO3, when we take this many moles and divide it into 2 liters, is this. Right, now we're doing 400. Now this dot means that all these zeros are significant. So we've got 3 significant figures here. But it's also in milliliters, which we can't use, so we need to change that to liters, 0.400. Keep all those. So our concentration is equal to our moles per liter. It's equal to 0.275 divided by 0.400. Right, now this number is going to get bigger because we're dividing it in a number that's between 0 and 1. So 0.275 divided by 0.6875. Which we make to three significant figures, 0.688 m. Now I'm looking at this last one, I'm thinking, man, I did something wrong here. Because this makes it bigger, right? We're dividing by a number less than 1, so it makes it bigger. How did I get a way bigger number here? How does 0.275 divided by 2.00 equal that? Well, it doesn't. I put in 2.75. It should have been 0.275. And that should give us, I hope some of you picked that up, 0.1375 is our concentration, which is equal to 0.138 m. There we go. That's corrected. Now we're just going to get more complicated. If 1.15 grams of lead-2 acetate is dissolved in water to make 75 milliliters of solution, calculate the solution of lead-2 acetate. I don't know what the heck this is. So we've got mass, but our solution, our concentration formula has moles and liters, so we can't use mass. We have to use moles. So we're going to have to do some work here. All right, so we're going to have to go from our mass down to our moles. Then we're going to have to go from our moles to our concentration. And to do our mass to moles, and we have to done this before, we have to do lead-2 acetate. Acetate is choo-choo. So lead-2 acetate is PbCH3COO2, like that. That's lead-2 acetate. So we have to find the molar mass of this. Now, I'm not going to do all the work. I'm just going to type this into my calculator in a way that I can do this. So I do lead, which is Pb, plum bum. Where is lead? It's down at the bottom. The right side of my page. 207.2, 207.2, and I times that by 1 because there's one lead, plus C is 12.011, and I times that guy by 4 because there's 4 of them. You can see how there's 4. There's 1, 2, and then we times those by 2, plus H is 1.008, and I times that by 6 of them, plus O is 15.999 times 4 of them, equals. Now see on my calculator, I just made it in one big long expression, 325.288 grams per mole. All right, so let's get working on our calculations. All right, so we're moving from mass to moles. Our mass that we know is 1.15 grams. So how many moles are in 1.15 grams if 1 mole has 325.288 grams? All right, we do 1.15 times 1 divided by that. So 1.15 divided by that number is equal to 0.00. And I'm just going to write it in here, 0.0035353 0.287. And this should have three significant figures, right? This guy has three significant figures. This guy should have three significant figures. But it's an intermediate step, so I keep it the same. Now we go to our concentration as our next step. So concentration is equal to our moles per liter. It's equal to 0.0035 ... That number's in my calculator still. Divided by, we've got 75, and this is 2 sig figs. And we do 0.075. And our concentration that we are going to get is equal to this number divided by 0.075, 0.047. And that's to our two significant figures that we should have, because this one had 3, right? Because this guy had 3, so this guy should have 3. And we're dividing by 1 with 2, so we should keep it have 2. So 0.047. That's our concentration. There's our answer. Okay. Number 3. Calculate the mass of H2SO4 needed to make 750 milliliters of 0.250 moles molar solution H2SO4. Okay, so we've got a concentration, right? So this time we're starting out with the concentration. We're going to go to moles by using our formula. Then we're going to go from moles to mass using our molar mass. All right, our concentration is 0.250 m. 3 significant figures on that guy. So to go from our concentration to our moles, we have to use our formula. M is equal to moles per liter. Now we know our M, 0.250, is equal to our moles, we don't know, and we know our liters. This is 3 sig figs here, right? The dot at the end means they're all significant. And we change that to liters, 0.750. Now to isolate our mole in this formula, we multiply both sides by 0.750 to get our moles as 0.25 times 0.75, 0.1875. And this should have 3 sig figs. But we keep the extra one because we're in the middle of a question. So we get 0.1875. All right, so now we need the molar mass of H2SO4 in order to do this. So I'm going to do the molar mass of H2SO4. There's 1.008 times it by 2 plus S 32.066 times it by 1 plus what do we got? SO4, 15.999 times 4 equals 98.078 grams per mole. Right, so to go from moles to mass, we write it up. How many grams are in 0.1875 moles if there's 98.078 grams in 1 mole? So I take this number, times it by that, and divide it by 1. I always mess this up. Times 0.1875. 18.389625. We want this to have 3 significant figures because this number here is supposed to have 3 significant figures. And in a multiplication question, we always keep the lowest number of significant figures. So this guy should have 3, so 18.4 grams. So if we have 750 milliliters of water, and we need to make this concentration of solution, we will need to add that many grams of H2SO4. Okay. See how I've got these maps always laid out. I always want to lay out the maps. Calculate the volume of the solution in which 8.78 grams of MgCl2 is dissolved in water to make this concentration. Okay, so here we have a mass, and we do have a concentration. So we're going to start with this mass. This will be our first guy. So we're going to go with the mass. We can always go to moles. And then from moles, we're going to go to a concentration volume using our formula. So our mass, we know, is 8.78 grams. And that's got 3 sig figs. So we've got MgCl2, right? So to go from mass to moles, we use our molar mass. So MgCl2, and Mg is 24.305 times that by 1 plus, we got Cl2, Cl is 35.435, 453. We times that by 2, 95.211. So you get a molar mass of 92. So we go. How many moles are in 8.78 grams if 1 mole has 95.211 grams? So I'm going to do the 8.78 divided by the 95. 8.78 divided by equals 0.92216236, and that's a 0 before the 9. 0.0. And I keep that. It should have 3 significant figures, but I keep more because it's in the middle of the question. That's how many moles we have. Now we got to go from moles to our volume of our concentration. So we use our formula for this guy. Concentration is equal to moles, which we know. We know our concentration, we know our moles per liter. So we know our concentration is 0.125. That's 3 significant figures, is equal to 0.09 ... That number's in my calculator. I'm leaving that in my calculator for now. Divided by my liters. This guy has 3 significant figures too, so our final answer will have 3 significant figures because that's the lowest amount. So I know when I don't know the denominator, I just swap these two guys and I get my liters is equal to my 0.09 ... divided by 0.125. So I take my thing, which is in my calculator, and divide it by 0.125. 0.7377. That's how many liters we need. If we have this many grams of MgCl2, we need this many liters of water to get this concentration. Now we're going to write our final answer with 3 significant figures because it should have 3 significant figures. So our concentration volume is 0.738 liters. All right, so that's how you work with this. I hope you understand the concept of concentration is moles per liter. Remember that. Make sure you know that because that's a big formula. All right, thank you for watching.